All right, welcome back to week 3 of Missouri Caves. I'm Doug Guzet again. I'm a professor of geology. And today I'd like to talk to us about how caves form and the history of our thinking about that. And so we call that the speleogenesis, the speleo being the word for cave, genesis being the creation or forming. And so what we want to do is figure out how caves form and how our thought has developed. And I'm putting up some slides, and you'll be able to see them way back in the 1700s. I'm going to start with a slide that just says pre-1900. And way back in the 1700s, one of the big names in geology, a guy named James Hutton, talked about fluvialism, that erosion is how caves form, that like we look at rivers and streams that have eroded into the hillside, the Grand Canyon eroded in by the Colorado River, we talk about caves were erosional features. And in fact, there were some other famous geology names, Charles Lyell in the 1830s and 50s, that sort of picked up on that, but said, you know what, there has to be something unique about caves that is erosion different from erosion elsewhere in the landscape. And the thing that they came up with, they added in the importance of carbon dioxide. CO2 is the chemical symbol for that. And as they went on, there were some others in the 1870s to 1890s that picked up. A guy named E.A. Martel talked about corrosion, that carbon dioxide helped corrode things like oxygen rusts metal out in the air. And then another guy named Edouard DuPont, and yes, that's the same guy with the whole DuPont chemical company, said, you know, that's another good concept, that erosion and corrosion and the importance of CO2 gases all play a factor in how we get the limestone to turn into caves. Now, Martel also did say something that I personally subscribe to. He said, no theory about caves is universal. He said, in fact, what we have is that caves really are different, and there have to be some differences in how they formed. He also took on, and DuPont really took on, the idea that caves can't form by streams alone or by river erosion alone. DuPont said there are no caves in schist. And schist is that lovely type of rock that forms in metamorphic areas that looks like sequins on a lady's dress. It's sparkly, large flakes of mica, and so they can be eroded fairly easily, even though they're a very hard metamorphic rock. But caves, we couldn't find any in there, and even in my modern day, can't think of any caves that I've ever been in that are in schist. So it did lead to the idea that there had to be some corrosion, some dissolving, some reaction between the CO2 gas and the water. And that got people into focusing, how does water dissolve rock? And that kind of takes us up to about 1900, about the start of the 20th century. And in the early 20th century, we had a number of people. One was a gentleman by the name of Svijic, and I hope I haven't butchered his name too badly. I'm not great at Slovakian pronunciations. And he related the karst development on the surface, the landscapes, the hillsides and the sinkholes and caves, to subsurface hydrology, to where water flows underground. And he came up with 3 zones then of the hydrology, the water flow. And that was a dry zone, a transitional zone, and a saturated zone. You and I today might call that transitional zone the water table. The saturated zone would be beneath it, and what he called the dry zone would be above it. We use different terms, but we do think in that terminology. So, kind of recapping quickly on that, before the 20th century, there were studies all over the place, a lot of people in Europe. A lot of the initial cave studies were done in Europe because the Yugoslavian and Slovenian karst areas were where people first really identified these unique landscapes of caves and sinkholes and streams that would disappear underground. And because they developed those there, then they would study them in individual little nations in Europe, and America was not even really a big necessarily player on the science world in the pre-20th century. So different scientists, even the ones that did come to America or to England, would have different locations, different caves, and studying them at different times. And so they would all come up with different theories, primarily tied to what cave they were studying. So they would have contradicting observations just based on where they were looking at their work, and their interests overlapped. So the big controversy that started in the early 20th century then is exactly how does groundwater move? In our modern world of geologic science and hydrogeology and all of our modern science equipment, we talk a lot about how water moves underground. But if you think back over 100 years ago, that's sort of a unique idea. How did water move underground? We know it would soak into the ground. We knew that springs would come out of the ground. But being able to see inside the earth is not an easy thing. Well, some of the early ideas we had were a couple of folks, Grund and Katzer, who came up with ideas that, like Svigik, they were looking at above the water table, below the water table, and the water table, or something like that. And they said, well, below the water table, we don't think that there are underground rivers. Sometimes you may hear people say that even today, that they think that when you get a water well, it's because there's a river underground that flows like the Mississippi River. And in fact, what we say is that the water moves between the grains of the rock, moves through like a sponge, and so the earth is more like a sponge than a pipeline. And so somebody who said the water tended to be stagnant and didn't flow like a river was actually tapping into our more modern thinking. Some of those same scientists in the early 1900s also said that there were very shallow depths of flow, that things became very stagnant very quickly below the water table. And so that's kind of how you have to think about it. And then you also wanted to think about, well, but if you go into caves, many of them have streams or river networks within them, streams that come together and flow as one big stream that came in from a side tributary. And so we have to kind of build those components in. And that takes us into about 1909, 1910, at which point we had a couple of people, and these are on your slides, gentleman Frank Green, who talked about the large passages of caves tended to be above what we call the base level of the streams. And in fact, he and another guy, Joshua Beatty, who was working in Indiana in the early 1900s, came up with ideas that as rivers cut down into the landscape, again like the modern day Colorado cuts into the Grand Canyon, they also pull the water table and these connected tributaries down with them. And so if a cave passage is dry, then either I had to lift the ground up to make that river cut down in, or the river had to cut down in and the water tables had to cut down in. And so these are the first people that got us thinking about how do water tables and rivers and streams and caves all connect with each other. There were a couple more people, George Mattson, you'll be able to see, that talked about the caves are most found at those shallow depths. They don't go very deep, or at least back in the early 1900s when you didn't have all the modern headlamps we do, people didn't explore them very deep. And there was even a gentleman, R.T. Walker, in 1928 who said, well, some caves were formed by cold descending water, water dropping from above like a cold waterfall or a cold shower, but that as water gets deeper in the earth, it heats up, and many people who had gone into coal mines and other deep mines would know that it's warmer deeper in the earth. And so they said as the water heats up, it ascends. It's sort of like a percolator in a coffee pot or a rolling boil in a stove, that hot water rises and cold water sinks. So he got people at least thinking about up and down circulation, not just the water table or not. And that took us to about 1923 with a guy named Oscar Meinzer. And he actually is a very famous person. He was considered sort of the father of American groundwater studies. He worked for the U.S. Geological Survey, and in fact they have an annual award named after him still because he was such a well-known guy. And he kind of brought in what we would call the classic period of American karst studies. American study of caves kind of really got exciting from about the late 1920s, around 1930, up until about 1942. And the big things that he got people thinking about, again, were these above the water table, below the water table, but it's time for us to give those some words. And on the slides, you'll see the two words we have are vados or vados, depending on how you want to pronounce it, which is shallow groundwater that is above the water table. It's water soaking its way down to the water table. Or phreatic water, which is water that is circulating underneath the water table, the water that goes to the water wells that we have. And so those were the two big types of water terminology that we have. And in fact, I've put in a slide where you can see that different theories abound even today. I've put in a slide from a modern scientist, Derek Ford, who shows that some caves might form above the water table by dissolving the rock as they fall through cracks and making wider passages like the large, wide, black pathways shown in the slide. Some form by dissolving the rock underneath the water table as the water circulates through it, and some form right at the water table. And in our next section, we'll talk a little bit more about that. But for today, let's stop right there in the first part of Lesson 3.